The Big Bang is the name given to an idea of how the universe started. In this video, we'll discuss the idea of applying triangular neighborhood networks to that problem. In an earlier video, I showed how we can start with very small triangular neighborhood networks consisting of only 4 nodes and 6 edges, and described how that size network can be grown to as large as we wish. Later on, in yet another video, I discussed the question of the extra-dimensional structure. Consider 2 triangular neighborhood networks coupled to each other by means of extra-dimensional edges. In this case, if each of these networks consists only of 12 5-edge nodes, consider the 2 triangular neighborhood networks coupled together by means of 12 extra-dimensional structure edges. These edges can have signals flowing in either direction on any of the extra-dimensional structure edges. And in the beginning, one could imagine that the flow of signals back and forth between these 2 networks might be uniform. In previous videos, we discussed the motion of signals at a given level and how at the next lower level a signal is represented by a toroidal hole. The motion of toroidal holes within a level is one thing, but the recursion of triangular neighborhood structure allows for the motion of toroidal holes up from one level up to the next level, or from one level down to the next level. This is a very important property in terms of the growth of the universe. At the first level, the universe has to be able to expand out into arms, and then at some point galaxies have to be able to form. At another level, perhaps stars form, and yet below that is the formation of atoms, perhaps particles. Assignment of names to a level is still very tentative. But the important thing is that here, that toroidal holes can move up to be able to fuel the growth at each of the levels. But the motion of toroidal holes down is more a question of local structure and the utilization of patterns. Somewhat later in the Big Bang, it might be possible that one of the networks has shrunk while the other network has grown. Shrinking can occur by motion of signals from one triangular neighborhood structure to the other, or by motion of toroidal holes up a level from lower levels to higher levels of structure. In any case, one can posit that this might have happened. Much later in the Big Bang, we might come to a situation where one of the triangular neighborhood networks has shrunk very dramatically, so that in the end, let's say there are only 12 nodes in this network, and this network here has grown to be very large. But again, there would be 12 EDS edges connecting this structure with this structure. So at this point, we would call this the fabric of the universe, and at this we'd call the EDS of the first level of structure of the universe. This diagram represents the second level of triangular neighborhood structure. At this level, each of the triangles in the first level structure becomes a toroidal hole. This is true for the outer surface, for the structure that shrank to be very small, as well as the edges that connect the small structure to the large structure. These become pipes filled with toroidal holes. That's why the diagram is shown in a very heavy black. The importance of this is that the volume, the central part of the larger structure, is itself filled with structure. And it might very well be that these edges here, the 12 edges that had formerly been the EDS structural edges, now become the attractor arms for the formation of galaxies. It might also be true that the places where the formerly EDS edges came to the surface, the places where the 5-edge nodes were located, that these may become the attractors themselves, and that this surface shown here as a vaguely spherical or icosahedral may in fact be quite convoluted in some sense. So there's no reason to think of this as a sphere. It could be a very complex structure all throughout the volume. And there may in fact be perhaps 12 attractors in the universe. I've brought back the level diagram and added to it the potential levels of a feature in the universe. The first level is concerned with the primitive growth of an evolution of the relationship between the fabric of the universe and the EDS structure that controls it. The second level is the evolution of the notion of the arms of the galaxy and their motion. The third level might be the evolution of galaxies, as we described in an earlier video. The fourth level might be the evolution of stars within galaxies. The fifth level may be the evolution of atoms within stars. The sixth level might be the evolution of the nucleus and the relationship to the total structure of the atom. And then the seventh level may be the evolution of particles. My sense is that because there's continual motion up and down these levels, and as the structures expand at each level, then all of these behaviors are happening simultaneously. Not necessarily in the same place at the same time, but at different places and at different times, with evolution of features occurring at all places and all levels. The Darwinian aspect of evolution is that features compete with each other until the most stable features at a given level develop, and then perhaps those features diffuse over that level for the whole universe. This slide summarizes the features of the triangular neighborhood networks in relationship to the Big Bang. The motion of toroidal holes upwards from one level to a higher level could be used to fuel the size and complexity of the universe. Each of these levels of the TNN structure is the evolution of some new set of structural features. The evolution of these features probably happens in what we consider to be a Darwinian fashion, that's to say, at many places and at many times, with the strongest features diffusing over the whole universe in time. The point to be made here, of course, is that the triangular neighborhood networks provide a uniform language for all levels of structure and behavior. And I think this is the real power of the idea that I've developed.